the large data set. Daily maximum gust. A gust is a sudden increase in the wind speed that doesn't last for any more than 20 seconds. So we've got the gust in knots, and we've got the direction of the gust and the compass direction. Now the cardinal direction here is something on the compass here, so you might have east, east, south, east, south, east, and so on. And here's an example. So we have a gust of 21 knots there, 21 knots, and the direction from which the gust is blowing is 100 degrees measured clockwise from north. On a compass it's blowing from the east. Here's another example. This time the gust has a strength of 39 knots, 240 degrees measured clockwise from north, west southwest there on the compass. That's the direction from which the gust is blowing. Daily maximum relative humidity. So we're looking at the saturation of the air with water. It's a percentage, which means the scale is from 0 to 100. So when we're looking at high percentages, we're looking at humid conditions. Low relative humidity means we're looking at very dry conditions. Above 95% gives rise to misty or foggy conditions. Daily mean cloud cover, measured in octaves or eighths of the sky covered by cloud. So the scale is 0 to 8, so 0 out of 8, 1 out of 8, all the way up to 8 out of 8. So a value of 6 means that 6/8 of the sky is covered in clouds. This is 4/8. A value of 0 would mean the sky is totally clear of all clouds. So 0 to 8 means there are actually 9 values inside here, starting from 0 all the way up to and including 8. Daily mean visibility. So the greatest horizontal distance at which an object can be seen. The units are unusual, decameters, and we need to know that 1 decameter is equal to 10 meters. So a value of 2,900 decameters means you take 2,900 times by 10, 29,000 meters. That means there is visibility of an object at 29 kilometers. Daily mean air pressure, measured in hectopascals, shortened to HPA. The average air pressure at sea level on the Earth is 1013 hectopascals, and on a weather map these lines show regions of equal air pressure. They are called isobars, and we know that low pressure leads to bad weather conditions like rain and strong winds, and high pressure leads to good weather. And we can see where we have high pressure, the actual values are higher relative to those values which are in regions where it's raining. For example, here these values are lower, these ones are lower. High pressure down here, high pressure here, lower pressure down here where it's raining. So low pressure meaning that you have bad weather. Sometimes you have missing data, N/A, like this. It means data is not available. So you may have to clean your data first, so remove these data values to be able to do calculations. So when presented with data in an exam, if you're given all of the data, so a census, then any conclusions you draw, you can be quite confident in them. If you've taken a sample, if the sample size is large, you can still draw some confident conclusions, but if you have a small data set, then the conclusions will not be so strong. And exam questions may typically include a small extract of the large data set. And once again, remember that I've gone into far more detail for the various weather-related variables than you need to be aware of. For practice, try these questions.